Hi student, I'm Bhawani Shankar, Assistant Professor of Chemistry, Sadique Faquir Government Boys Degree College, Mithi, Tharparkar, Sindh. So today we have another important topic to discuss, and that is oxidation number. So in oxidation number, what we have to discuss and to determine the oxidation number. So oxidation number is what we have to say is it is a formal charge or apparent charge on atom of molecule of the compound or ion. So what do you mean by that? So why we have to say it is formal charge? Why we have to say it is just apparent charge? Because it is not a fixed charge. So whenever we have ionic compounds, in those ionic compounds you can find the formation of ion by the loss by the gain of electron. So as you know, when any atom losing one electron can make a fixed oxidation state of +1, or if it can lose two electron can make +2. Likewise, we have another side when you have non-metals where you can find the gain of electron. If it is 1 can make 1 negative, and if it is gaining 2 can make -2. So those oxidation states are fixed in the ionic compound. So matter of fact is that we have a determination. So that determination is involved covalent compounds. As you know, how covalent compounds are formed by a covalent bond. So covalent bond is formed by mutual sharing of electron. So we have no any positive or negative things they are to be developed. But in those compounds, what we have to do, we have to choose element, atom from the compound or even from the ion, and then we have to check the oxidation number. So that determination, it is based on certain rules, because as you know we have the covalent compound. So how we can first convert covalent compound into ionic compounds? Because you know, again I have to say, whenever you have a covalent bond, we have no any involvement of loss or gain of electron. So what we have to do right now, whenever you have a covalent bond, so first we have to convert its character from covalent to ionic, and then we have our rules for the method of determinations. So likewise, we have to take example how we can convert any covalent compound into ionic. So we have the structure of water, and you have to check to that water. So in water you can find a composition like this one. As you know, oxygen, as far as its valency is concerned. So now I want to describe certain word which can differentiate the term valency and the oxidation state. In valency, just we have to mention what the combining capacity of the element means. Any element, its atom, how much it can have the ability to link with the other one. So likewise, we have to say oxygen is a divalent. So no need to mention that it should be either positive or negative, because whenever you have to put positive and negative, that description of positive negative can describe the oxidation number. So that's we have to say differentiate between the valency concept and the oxidation number. So oxidation number, and if it is written apparent or formal, means not a fixed one. So in certain elements of the compound you can find the same element but have got even positive. If it is positive, then you can find the different positive like +1, +2, or even it may be -1, -2, means both things may be changed, that is number as well as the charge. So that's why that can give the concept of term like formal or apparent. So in this compound, as you know what I mentioned it, that we have a water, it is a covalent compound. So how you can convert it into ionic? So in this compound, oxygen is a divalent, means we have to take the number from valency, and it is a divalent, it is more electronegative, so we can mention, so it is divalent and it is more electronegative, we can express it by -2. Hydrogen is a monovalent and it is a less electronegative. So monovalency is shown by +1 and less electronegative means more positive. So that's why we have to put a plus. So these plus and minus, these plus and minus are with number. So earlier we are known that a covalent compound, if you can have the compound of different elements, then you can just we have a partial character. But now we mention those characters by number. So likewise, as you know, this compound has whole. Again, H2O, we have 2 hydrogen atom, and you know the oxidation number of +1, and we have 1 oxygen -2, and as whole the charge is 0, means all molecules of the compound. All molecules of the compound, they are always neutral. They are always neutral because the number of positive and negative charges are equal. So they are cancelled out, and that's why they have got overall oxidation number of 0. And as far as the rules are concerned, so whenever you have any neutral atom, it may be a metal or non-metal. You can find all those metals and non-metals with oxidation number of 0, like sodium, we have a potassium, we have a hydrogen, we have chlorine, we have oxygen. Whatever the atoms we have, they are to be considered as what the oxidation number of 0, because neutral atom means have got equal number of electron and proton. And we have molecules like homonuclear, yes, they again have the oxidation number of 0. So that's, we have hydrogen molecule, we have bromine molecule, we have chlorine molecule, we have oxygen molecule, we have nitrogen molecules. Means all these molecules, they have the oxidation number of 0. And we have a compounds, means the molecules of the compound, definitely they can also have the oxidation number of 0, because the number of plus and minus charges are equal. So next we have to check those elements, you know, particularly in the compounds can show a different oxidation number, means it may be sometime plus with different number and sometime minus as well. So the best example of those we have like oxygen. As you know, oxygen in normal oxides, always possess oxidation number of -2, possess oxidation number -2. Likewise, magnesium oxide, look at that, you can find magnesium metal belong to the second group, we have fixed oxidation state of +2, and definitely oxygen become -2. So when oxygen is a negative or possess oxidation state of -2, we have to refer it as normal oxide. This is to be referred as normal oxide. So we have many examples of those where you can find oxygen with oxidation state of -2, but you can also find oxygen in peroxides. In peroxides, you can find possess oxidation state -1. So we have peroxide like sodium peroxide. You can find sodium peroxide where you can find sodium. Yes, we have 2 sodium atom, each one possesses oxidation number of +2. We have 2 oxygen, and as whole compound is neutral. So we have +2 plus 2 oxygen atoms, we have neutral, and further 2 oxygen, we have 2 plus is to be shifted, become 2 minus, and oxygen minus 2 divided by 2, it become minus 1. So we have to mention the oxidation number always with charge. Without charge, we have number having no means of that. So this is what the peroxide. And similarly, when you have superoxides like certain compounds which possess such superoxides, then you can find the oxidation state of that, how it is to be changed or be varied. So in this regard, we have another option where you can find in superoxides. In superoxides, it possesses oxidation state of, you know, minus half. Like we have potassium superoxide, like that. Or rest of rubidium, cesium, where you can find, and this is one potassium having fixed oxidation state of +1. We have 2 oxygens, and as whole compound is always neutral. So neutral means possess oxidation state of 0. And in this case further, if we have to check to those that how we have further calculation, it is +1, yes, +2 oxygen, it is 0, and we have 2 oxygen. This oxygen is to be 1 is to be shifted here, become -1, and oxygen, it is minus half. So what we have the finding up to this one? We have in all compounds the oxygen possesses the charge of minus with number like -2, -1, minus half. But in certain cases like in oxygen fluoride, here the case is different. Where you can find oxygen, we have to determine oxygen, its oxidation number. We have 2 fluorine, and as you know, fluorine is more electronegative than oxygen. So it is a monovalent, have to put -1, and as whole compound is, you know, neutral. So oxygen -2 is equal to 0, and the oxidation number of oxygen, when this 2 is to be shifted, -2 is to be shifted to the right, become +2, and in this case you can find the change in the charge as well as the number. So this word which we came in the earlier part, the formal are apparent, and this is apparent, minus, plus, with change in number can express this one. So likewise we have so many other compounds you can find the oxidation number of different element it is to be changed. We have example of hydrogen. As you know, hydrogen in most of the compounds means when it is combined with non-metals can have the oxidation state or oxidation number of +1. Why? Because you know all rest of the non-metals they have more electronegative characters than hydrogen, and that's why hydrogen is less electronegative, means it is positive. And in combination, when hydrogen comes in combination with metals, you know, where it can show what both, I mean from +1 to -1. So likewise, if I have to mention those compounds in which you can find hydrogen fluoride, here it is +1, and if we have a combination where you can find like sodium hydride. So look at that. This is +1, this is -1. So this is +1 and -1. So that can again make it formal or apparent. And in this combination, we have a combination with non-metal. This is in combination with metal. So likewise, you can find a variety in changes like in chlorine. That's halogen. So halogens halogens we have a different compounds, and you know in ion combination mostly chlorine is -1, that it possesses oxidation state of -1. But when you have a covalent combination with many other compounds where you can find hypochlorous acid, hydrogen chlorate, hypochlorous acid, we have a caloric acid. So all these, in those you can find the oxidation number of chlorine. It may vary from -1, we can say +1, then you can find +3, +5. So these are the oxidation states which we can have in hydrogen when chlorine. Likewise, in hydrogen chloride you have hypochlorous acid, and then you have HClO2 chlorous acid. We have like that 3, and as well as means we can say it ranges from -1 to +7. Means we have the change in the charge, we have also change in the number as well. So that can make it what I can say. So these are the certain rules which we can apply for any determination. So again we have to follow to certain examples in that how we can determine the oxidation number of any element. In those examples we have to take first like sodium thiosulfate. This is one of the example where you are asked, you know, determine the oxidation number of sulfur. So how we can determine? You know, first you have to check to that as whole your compound is neutral. Your compound is neutral. So with the help of these two elements, that sodium, it is a metal, we have oxygens, non-metal, and from the oxidation states we can determine this one. So how we can determine? Again, 2 sodium, each one possesses 1 oxidation number. We have 2 sulfur atoms, we have 3 oxygens, possess oxidation number of -2, and as whole compound is neutral. So what happened? 2 plus 2 sulfur -6 is equal to 0. We have 2 sulfur and these numbers are to be shifted, +6 and -2. Then you have 2 sulfur, it is +4, sulfur, it is +4 divided by 2. So we can say the oxidation number of sulfur in sodium thiosulfate is +2. So that's the way to determine the oxidation number of your element. And right now we have another example where you can find the oxidation number of element by taking example this is what we have, bicarbonate ion. Look at that, bicarbonate ion. And in bicarbonate ion we have the determination number, oxidation number of carbon. That's the question mark. Oxidation number of carbon in hydrogen chlorate ion. And you know, again hydrogen, what it is number 1. We have oxidation state of hydrogen in this compound is +1 because it is in combination with non-metal. So it is what we have such carbon. We have 3 oxygens, means each one possesses oxidation number of -2. And right now look at this one. In this compound there was what we have overall charge, it is 0, that was neutral. But in this case we have oxidation number of -1 because we have an ion in this case. Because in the definition part we can have another aspect other than the molecule of the compound. the ion. So over here, if it is negative, then just to write like this one, and if it is positive with number, so have to mention the positive. So plus we have carbon, we have 6 minus 1, we have carbon, and you know this is to be shifted, plus 6 minus 1, and we have another minus. So what happened? We have oxidation state of carbon and bicarbonate ion or hydrogen carbonate ion, it is plus 4. So that's what the ion, the example of ion. So here that was any compound, and now we have the ion. And if we have to take another example like positive ion, so that can also to be done. Nitrogen in ammonium ion. Likewise, that we have to determine. That's the question mark. So ammonium ion, it is nitrogen which is to be determined, means oxidation number. We have 4 and we have plus Y because hydrogen is less electronegative and it is a monovalent, and as whole it possesses oxidation number of plus 1. So nitrogen plus 4 is equal to plus 1. This 4 is to be shifted on the right, and this is become negative plus 1, and as you know the oxidation number of nitrogen in ammonium ion is minus 3. So we have so many examples where you can determine the oxidation number. So I have another example, carbon and glucose. Carbon in glucose. Yes, that's we have a question. Carbon and glucose, yes, we have C6H12O6. Right now, you know, 6 carbons, we have 12 hydrogens, each one possesses oxidation number of plus 1. We have 6 oxygen, each one possesses oxidation state of minus, and as whole compound is neutral. So what we have to do the next? The simplification. 6 carbon plus 12 minus 12 is equal to 0. Plus minus are to be cancelled. So C6 is equal to 0, and carbon, when 0 is to be divided with any number, you have a 0. So 0 cannot have what the oxidation number plus or minus. So in this case I can say just you have the oxidation number of carbon is 0 in glucose. So that's what we have the method through which we can determine the oxidation number, either of what the atom of the molecule of the compound, or ion may be positive or negative. So that's all it for you. Thanks very much.